Okay, so we're going to go over this test review. I'm going to go over a part of it with you and then post an answer key for the rest. So this first part asks us to fill out the table, a few definitions of some important key terms. So the first one says, what does CPCTC stand for? If you remember, CPCTC stands for congruent parts of congruent triangles are congruent. And that is where C, P, C, T, C comes from. All right. The next one is a triangle midsegment. What does triangle midsegment mean? Well, the triangle midsegment is a line segment formed by connecting the midpoints of two sides of a triangle. So to draw an example of this, if I have a triangle here, let's say it's A, B, C, and I create the midpoint of AB, label it D, and the midpoint of AC, label it E, then I've created the midsegment DE. There's some special properties that we get about midsegments. The first one is that the midsegment is always parallel to the side of the triangle it does not touch. So here, DE is parallel to side BC. There's another property that relates those two, and that is that two of the midsegments would make up the length of that third side. And so we can write an equation that says 2 times the midsegment equals the length of the third side. The next one that we have is the centroid, and the centroid is the point of concurrency or intersection. That's what that word means, is just the intersection of the three medians of a triangle. So if I've got a triangle here, the median is the point that connects the vertice of one of the angles in the triangle to the midpoint of the other side. So a triangle has 3 vertices. It's the 3 points on the triangle. So the median connects one of the vertices to the midpoint of the opposite side. And then where all 3 of these intersect each other, that is the centroid. Now what's cool is that the centroid actually breaks up all the medians into the same ratio. It's a ratio of 2/3. Let's just look at this main median right here down the straight middle. So I'm going to label my points A and B. The way that it breaks it up, we get to write a formula, and the formula is 2 times CB, which is the smaller portion of the median. CB is smaller than AC, equals AC, which is the longer one. If it's ever not clear, the other way to tell is that CB is the one that touches the midpoint versus AC is the one that touches the vertice. And so the one that touches that vertex is the longer piece. The one that touches the midpoint is the smaller piece. And then we can use that equation to solve. All right, here number 2, it says solve for the indicated values. Line segment EG is a blank. Well, notice EG is right here and it connects the midpoints of the two sides, so that would be a midsegment. How many EGs does it take to equal DH? DH is this third side here. We know it takes 2 midsegments to equal that third side. And we're going to use that to set up our equation. So to do that, we take 2 times EG, and it should equal DH. But now we actually have some information about EG and DH. So I'm going to plug that in. See, EG is represented by this expression right here. So I'm going to write 2 times, and now I'm going to plug in 3x minus 10. Equals, DH is represented by the expression right here. That expression would be 5x minus 12. Now I have an equation to solve. The first thing you want to do when solving is to get rid of any parentheses. So right now I have 2 times parentheses 3x minus 10. I'm going to start by distributing the 2. So 2 times 3x is 6x. And then 2 times negative 10 is negative 20. Bring down the other side of the equal sign. And now I'm going to draw my line for the equal sign, and I'm going to start actually solving. When I solve, what I'm trying to do is get x on one side of the equal sign all by itself. So I look at this equation, and I want to try to find the smallest x term. I have 6x and I have 5x. The smallest would be the 5x. And so that's the one I want to move first. Remember, when we move, we do the opposite. So the opposite of a positive 5x would be negative 5x. Whatever I do to one side, I have to do to the other. So here, 6x minus 5x is 1x. Bring down that minus 20. 5x minus 5x is 0. Bring down the negative 12. All right, the next thing I want to do to get x by itself is to move that minus 20. The opposite or inverse of minus 20 would be plus 20. So I'm going to add 20 to both sides to move it away from x. Bring down the x. Negative 20 plus 20 is 0. Negative 12 plus 20 is 8. So here we've just solved for x. All right, now let's find the next pieces. So next it asks us to find EG. Well, again, EG is represented by the expression right here, 3x minus 10. But now we know what x is. So to find EG right now is 3x minus 10. I'm going to plug in 8 for x. And then I just simplify by following the order of operations. So I'll start with 3 times 8, which is 24. Minus 10 is 14. So EG is 14. The last piece asks me to find DH. So here's DH right here. And I'm going to plug in 8 for x. So 5 times 8 minus 12. 5 times 8 is 40. Minus 12 is 28. Now, another way you could do it is once you found EG, remember we said you take 2 of the midsegments to make up that third side. It is good to plug in just to check your work, but that's also another way to check as well. All right. Number 3, point D is the blank of triangle ABC. Well, it looks like BF, AE, and CG are all medians, and D is where they intersect, making point D a centroid. All right. If CG is 9x plus 12, let's highlight CG. So CG is this whole line right here. If CG is 9x plus 12 and DG, so DG is the smaller piece, is 4x minus 4. Solve for DG. Well, usually we compare the small piece of the median to the larger piece of the median. But what we have is the whole. How can we take the green section and use the pink section to find DC? DC right here is what I want to find. What I can do is I can take CG, the whole, and subtract DG, the small piece, and it will equal DC, the piece that we want. So to do this, I'm going to take CG, which is 9x plus 12, and I'm going to subtract DG, which is 4x minus 4. When I go to do this, I want to start by distributing the negative. So it becomes 9x plus 12 minus 4x plus 4. And now I'm going to combine like terms. So I've got 9x minus 4x is 5x. And 12 plus 4 is a positive 16. So now this expression represents the line segment DC. So now I can use this to plug into our formula and solve. The formula when we have a centroid is that 2 of the smaller piece, which is DG for us, equals the longer piece, DC. So now I'm going to plug in what I know. DG is 4x minus 4. And set it equal to DC, which is 5x plus 16. All right, I'm going to start by distributing the 2 because I want to get rid of the parentheses. 2 times 4x is 8x. And then 2 times negative 4 is negative 8. Equals 5x plus 16. I'm going to draw the line for my equal sign and start solving. I want to move the smaller x first, so that would be the 5x here. I'm going to subtract it because that is the opposite. 8x minus 5x is 3x. Bring down the minus 8. Equals 5x minus 5x is 0. So bring down the 16. The next thing I want to do is add over the 8. Because I'm trying to get x by itself. And so now I have 3x equals 24. And I'm going to move over here. Now, x is still not by itself. Right now it's 3x equals 24. Remember, 3x is really saying 3 times x. So the opposite of multiply, or the inverse of multiplication, is division. So since it's 3 times x, I'm going to divide by 3 on both sides. So x equals 8. Now I want to find EG. EG is not what I want to find. That's incorrect. It should say DG. DG is this piece right here, and we know it is represented by this equation. So 4x minus 4. I'm going to take 4x minus 4, but now I know what x is. So I'm going to plug in 8 for x. So 4 times 8 minus 4. 4 times 8 is 32. Bring down the minus 4. 32 minus 4 is 28. So DG is 28. Number 4 here says to fill in the statements below by matching which line segments should be parallel. Remember, the mid-segment is always parallel to the side it does not touch. So for the first one, A, I'm looking at mid-segment NL right here. Point N is on the side of the triangle labeled FE. And point L is on the side of the triangle FG. So what is the only side that we don't touch with this mid-segment? It would be the side right here, EG. And so therefore, I can say that NL, line segment NL, is parallel to line segment EG. For the next one, I'm looking at FG. FG is this side of the triangle. Which midsegment does not touch the side FG? That would be this one right here. And visually, they look parallel too, right? So I would say that line segment FG is parallel to line segment NM. Now we're looking at line segment NM. That's this right here. We just did that, right? It does work both ways. So NM is parallel to line segment FG. What if we wanted to write one for the one midsegment that we haven't been asked about? Okay, what would be that last one? Well, here is midsegment LM. And I could say that that midsegment LM is parallel to this side FE. All right, number 5 is looking at a problem where I have the centroid on a median of the triangle. Here I'm given that line segment CD is 5. Well, I know that 2 times the small piece of the median equals the longer piece of the median. So 2 of CD equals AC. So now I can use this equation to plug in what I know. I know that CD is 5. 2 times 5 is 10. So AC must be 10. All right, now let's find AD. Well, AD is asking for the whole distance of the median, the total. We know that CD is 5, and we just found that AC is 10. So to find the total distance, I would just add them together. 10 plus 5 is 15. 6 is similar, so I will leave that one for you. Let's just look at one of the midsegment problems. So here, number 9, this is a midsegment. I know DB is the midsegment, it's inside the triangle, and the side it relates to is EA because they're parallel to each other. We always write our equation as 2 times the midsegment equals that third side. And now I can plug in what I know. So 2, I don't know what BD is, equals EA is 25. Now I want to solve this for BD. Right now it says 2 times BD. So to cancel out that multiplication by 2, I would do the inverse, which is to divide by 2. And remember, you have to do it to both sides. So when I divide, 2 divided by 2 is 1, so I'm left with BD equals 25 divided by 2 is 12.5. And so that is the answer here.